Temperature control is the #1 issue faced by owners and operators of pharmaceutical warehouses. The Medicines and Healthcare Product Regulatory Agency, or MHRA, is the government body that controls standards within the pharmaceutical industry. John Taylor is the Quality and Standards Manager for the MHRA. He's the leading authority on this subject and is greatly respected by all parties in the industry. We asked John, what's the greatest challenge facing the pharmaceutical industry with regards to the storage of medicines?
Well, the greatest challenge concerning the storage of medicines is to ensure that products are stored under conditions compatible with maintaining their quality. And in this regard, of prime importance is the control of storage temperatures such that products are not exposed to extremes of temperature outside their labelled storage requirements.
Why has this all of a sudden become an issue?
It's only during the last 10 years or so that regulators and industry in particular have recognised that distributors have a very important role to play in maintaining product quality from manufacturer to patient.
The points raised by John are only part of the problem. There are other issues which not only affect the pharmaceutical industry, that add to the problem of temperature control. First, we're seeing great improvements in warehouse construction, and as a result of tightening regulations, buildings now require less energy to keep warm in winter, with the emphasis now changing to keeping them cool in the summer. Additionally, the use of ever-increasing amounts of mechanisation in warehouses and the addition of mezzanine floors means that warehouse temperatures are increasing. Add to these issues the effect of global warming. It's widely accepted that global warming is a reality, and summertime temperatures are ready to increase beyond the record-breaking temperatures of the summer of 2006. Research shows that global warming is directly related to the increasing volumes of greenhouse gases, with CO2 being one of the main offenders. This graph shows outdoor temperatures recorded at the London Weather Centre. Typically, for a warehouse to comply with MHRA requirements, some form of ventilation will be needed once the outside ambient reaches 18 degrees. Once the external temperature exceeds 23 degrees, you will need to use some form of mechanical cooling to keep internal temperatures below 25 degrees. As you can see from the graph, 18 degrees was exceeded on a significant number of occasions during the 5-year period, nearly 150 days per year in fact. Excursions above 23 degrees, although less numerous, occurred on over 60 days a year. We asked John Taylor to explain, during the inspections that were carried out last year, what were the majority critical and major deficiencies in GDP, and how were these failings addressed by the MHRA?
Well, the majority of critical and major deficiencies, these we class together as serious deficiencies, reported last year, concerned temperature control and monitoring in general storage areas.
It's apparent then that unless some form of ventilation or cooling plant is installed in these warehouses, it's often difficult to fully comply with the recommendations. Here we show a typical pharmaceutical warehouse in summer without any form of ventilation or cooling. What you have is excessive levels of stratification, as the hot air accumulates at high level in the warehouse, making the top levels of racking unusable for certain temperature-sensitive products. Some distributors have to relocate stock to lower levels and even put the stock close to open doorways to keep cool. This can be further aggravated where MHE and mezzanines have been added. A warehouse in the UK without either ventilation or cooling cannot comply with the manufacturer's storage requirements and MHRA standards. So, what alternative do warehouse operators have? Install a jet air induction system. So, what is an air induction system? It's the most energy efficient and low carbon method of cooling and ventilating a pharmaceutical warehouse. The system offers even temperature distribution and minimal levels of stratification. Temperature sensitive products can be stored anywhere within the warehouse without fear of being in breach of the manufacturer's temperature storage requirements. With its flexible design, the system is easy to modify if the warehouse layout is changed in the future. The system relies on mechanical cooling only when it's needed. At all other times, it utilises fresh air for free cooling of the space. Here's a plan of a simple system. As you can see, we have a large number of nozzles. As a result, we can guarantee a very close temperature tolerance within the warehouse, usually around plus or minus 1 degree Celsius throughout the entire space. Mechanical cooling is a solution to address the MHRA temperature requirements. However, on its own, mechanical cooling is very expensive to run, consuming significant electrical energy, producing higher CO2 emissions. The JET pharmaceutical solution is designed to maintain temperature conditions and meet MHRA standards, doing so in the most energy and cost-efficient manner. The majority of the time, the internal warehouse temperature can be controlled at an acceptable level by utilising free cooling. Free cooling is where cooler outside air is supplied in large volumes to maintain the building temperature within its required parameters without the need for additional mechanical cooling. During the summertime, when there are high daytime temperatures, the plant will continue to run overnight, bringing in the cooler night air to lower the internal temperature of the building mass. This process is known as nighttime purge, and it reduces the amount of cooling required during the daytime, thus reducing running costs. To give you an example of this, during the summer of 2006, when we had record daytime temperatures of over 35 degrees, the corresponding nighttime temperature was only 14 degrees, thus giving a massive 11 degrees of cooling from the nighttime air. When the space temperature rises to 25 degrees, the plant operates to provide minimum fresh air, as typically the outside air temperature will not offer any free cooling. At this point, the chiller plant will commence to run to maintain the required internal condition. As the outside temperature increases, the chiller plant will increase its cooling capacity until such time as a state of equilibrium is met. For pharmaceutical warehouses within the UK, we design our systems to achieve an internal temperature of 25 degrees to comply with the MHRA requirements without factoring in mean kinetic temperatures to show compliance. Outside temperature is based upon 35 degrees. This we find to be sufficient with the current UK climatic conditions. The temperature sensors used to control the system can also be used to monitor and capture temperature data for MHRA reporting purposes. The appropriate number of sensors can be incorporated in the system to deal with the more detailed temperature mapping which is required by the MHRA. These are a few of the companies in the pharmaceutical industry who are now benefiting from using a JET air induction system. What can JET do for you? JET can review your existing operations to design and install a system to ensure that MHRA regulations are maintained with the lowest running costs and the lowest carbon emissions. In addition to supplying a ventilation and cooling system, JET can incorporate a comprehensive temperature monitoring and logging facility within the design. The controls allow for the operation of the system to be remotely monitored to ensure that action is taken in time to ensure the space does not move out of the desired temperature range. If required, the operation of maintaining, monitoring and reporting temperature can be outsourced to JET for the life of the building. The JET air induction system is the most energy efficient, low carbon system available for heating, cooling and ventilating your warehouse to achieve compliance with manufacturers' storage requirements and the MHRA guidelines. The system can be simply retrofitted into an existing warehouse with minimum fuss and disruption. The system offers both even temperature distribution and minimal stratification. As all the plant is outside the operational space, there is no loss of valuable storage space or warehouse downtime during maintenance visits. We asked John Taylor of the MHRA what happens when things go wrong and what actions can the MHRA take against those companies infringing the regulations.
Right. Okay. Well, the most serious issue when something goes wrong is the risk that may be presented to patient safety through inadequate handling of medicines. But of course, there are implications for the company concerned. Expensive recalls, for example. We've had recalls costing in excess of £1 million. Consequent loss of confidence in the company by its customers and also by the agency, of course. There can also be regulatory action by the agency in the event of serious non-compliances. This may involve suspension of a manufacturer's or wholesale distribution license, compulsory variation of the license to exclude certain activities, revocation of the license in extreme cases, or sanctions against the qualified person or the responsible person. The person's nominated on licenses as responsible.
To conclude, Both internal and external temperatures are on the increase, and control is more critical than ever. The MHRA is tightening up on their inspections and taking action for non-compliance. Legislation is also forcing companies to look at and reduce their carbon footprint. And as John Taylor just said, the implications for companies that let things go wrong are significant. For more information, visit the JET website at www.jetenvironmental.com or call Steve Ball on 0121 788 5319.